Okay, right, so it's just effectively, to use James's term, it's just a little shot of CoffeeScript. So all I'm proposing to do in this talk is to give you enough for you to decide whether or not you want to go and have a look at it. There's a lot of resources out there for it, there's some good books. So what really interests me in languages, though, is also knowing a little bit about the history about where CoffeeScript came from. So I'm going to start just with a little lightning talk on the on the history of CoffeeScript and where it came from. So let's take it a little bit further back from that. So JavaScript, well, that was created by Brendan Eich, this guy. Brendan was working for Netscape at the time. This was back in 1995, and he was working on creating a scripting language which would run in the browser, which was kind of a nice new idea. And he had been playing with something for a little while called Mocha. And Mocha was effectively his scripting language, which was a bit richer than the JavaScript that they actually went with. At the time, Sun Microsystems were really pushing Java as the language for writing web applications, and so Java was very much the hype and the noise that Netscape were actually engaging with. So they thought, well, it's web, Java's web, we got this relationship, let's call it JavaScript and let's make it a little bit more Java-y. So really the idea was that this guy had to take what he'd done, his baby, and he got 10 days in which to turn it into something that looked more like JavaScript, but not as sophisticated as Mocha. So he was a little bit disappointed with this brief, but went on to get it done because he knew that there was competition in this space. If he didn't get it done, someone else would come and fill that gap. Scripting on web pages, well, it was a no-brainer at that point. It had to happen. So he pushed forward. So that was in 1995. Well, in 1999, Microsoft came up with the idea of XML HTTP. So effectively, they introduced that into Internet Explorer, and what that enabled the web pages to do was a web page could go and request more data from JavaScript without having to refresh the whole page. Go get snippets or make updates to the page. Now that introduced some interesting things, and a lot of the other browser vendors they caught on. They introduced the same patterns, and Google Mail came out, which was really using a lot of this technology. But it wasn't actually until 2005 at a conference that the term Ajax was introduced. And effectively that concept, that buzz around Ajax for whoever was in the industry doing internet applications, web applications at the time, would have heard of Ajax and all the ideas that it started to emerge from that. And so I'm trying to remember what the Java Posse relationship was in there for, but I'll come back to it. So they do have a podcast, and on their podcast they were talking about it, but I'll come back to that point in just a minute. So at a recent JavaScript conference, this guy, Matthew, what's his name? Sorry, notes. Come back to me. Where is it? Jeremy Ashkenas. Great, I shouldn't have moved. Sorry guys. So this guy, Jeremy Ashkenas, decided that JavaScript's great, it's a powerful language, really like the language, like the things it can do. But the syntax is just, well, I don't like it. It's verbose. In areas, it's just a lot of the things I do, I feel that I could improve on it. So he started working on CoffeeScript, but he didn't work on it with the idea as a replacement for JavaScript, but he worked on it really as a JavaScript plus, as a JavaScript version 2. And he actually talked at the conference with Brendan Eich, who effectively said, actually, I totally agree, and I think this is the direction that JavaScript should go in, or rather it should embrace the idea of it being expandable, of changing and repairing some of the damage that original decision that said, let's squeeze JavaScript out in 10 days from MockerScript and make it the bastard child of Java. So that's really the evolution to CoffeeScript. And in order to work closely with JavaScript, CoffeeScript effectively is transcompiled to JavaScript. So when you look at CoffeeScript, if you're taking a bit of time to work out the syntax and the understanding, you can quickly compile it to JavaScript, have a read through the JavaScript. It's actually intended to be quite readable, the stuff that you get out. So that eases the transition a little bit. So I can thoroughly recommend for after the presentation that if you want to get more information, the CoffeeScript documentation is very good. So take a look. It gives you a bunch of examples. So there'll be plenty of stuff that you can go and play with for your own research. But what I'd like to do now is move on to a little bit of hands-on. What does CoffeeScript look like? So this isn't CoffeeScript. This is JavaScript. So what I'm going to do is I'm just going to take a couple of exercises. I'm going to work through them and just show you how this morphs from JavaScript into CoffeeScript, and then show you that compile step on what the outcome looks like. So if we take an example here, we're just declaring an anonymous function to square an input. So first off, the var keyword isn't required in CoffeeScript. Okay? So in fact, it's not only not required, if you put it in, it will break. It doesn't like it. Secondly, anonymous functions. Well, anonymous functions are declared without the need of the redundant function keyword. So we're starting to slim it down. Now, one of the inspirations for the language was Python. And Python doesn't use semicolons and it doesn't use braces. It uses meaningful white space. So anything that comes within the body of the function is seen as, which is indented, is seen as part of the function. As soon as you dedent back, you're on to the next function. So one other bit, to declare this as a function, I say that square, taking the argument x, relates to this body. Now, also the return keyword, everything in JavaScript is an expression. So everything returns automatically. So the last line of your code, much like with Scala and Lisp, your last line is implicitly, the result of it is the return statement. So we stripped it down a bit, but because we all like code to be small, it's a one-liner. So what that gives us is, when we compile it, it looks very similar to what we had before, other than the fact that we declared the variable in the line above, but due to scoping rules and the way it works, it's just kind of the output you get. But as you can see, I mean, it's correctly indented, it's not minified JavaScript, it's quite readable. So that's when we're dealing with functions. Now I'm going to take a slightly different idea. One thing that we do a lot when we're dealing with consuming REST APIs, so something that we've used a lot in the product that we're working on at the moment, which is AFU, the Agent Facing Upgrade Shop, is iterating over lists. So we get back a bunch of handsets and we want to display them, we need to iterate over them. So in this example, we'll actually have a look at iterating over the list of numbers at the top. And as we can see, we're just over each one turning it into a square of that value. So to make this, so I'm just making this into a block comment so that I can implement it underneath. So I'm not sure if anyone's familiar with the idea of list comprehensions, but this is something else that it probably exists in a bunch of other languages, but being a Python fan, I know it most from Python. So if we look, well, we'll remember from the function syntax earlier that now we've effectively declared our function. We don't need the var argument. Now, what we're going to do is we're going to write our for loop, and we're going to pull each number and then we're going to do something with it. Now, what we return, the expression that's called, is actually put at the front, so we're then going to do now. Again, just fits. Okay, so again we've turned effectively looping over, creating a separate array, putting the values in, very traditional pattern to development, a very traditional pattern to looping over and creating another list. Is instead we've declared this as a list comprehension, and it effectively gives us the same thing as above. Now, because numbers is currently declared as a var, that won't let me compile it to CoffeeScript, so let's turn that into something else, and let's comment out the bottom function, and we'll see whether or not this actually produces some valid CoffeeScript. Please work. Yay! Okay, so we can see that. What can we see? So we've got our commented out version. Where's my actual version? Got lost.
List square, that bit.
Yeah, list square. So that's my actual function. So we can see that it's still a for loop. It's still iterating in a very familiar way. It effectively, all right, the syntax looks a little bit different to the example of JavaScript that I produced, but you can kind of see there's similar enough to call it the same thing. So in my second example, what I want to do is I want to filter a list. Common enough. I want just the handsets that are worth more than £50. So I might want to.
Can you just go through that?
Sorry, that
step by step.
That comprehension again, yeah. Certainly.
Is that returning a list?
So this, because it's an expression,
yeah,
it automatically returns the result of the last thing it did. But to take Alistair's request, let's break it down a bit. So for number in numbers, well, if we look at our list of numbers at the top, so loop over each one, assigning. So it looks very, the for bit looks very familiar. Yeah. What it's doing is the result of looping over. For each number, it applies the function. So whatever is at this part is returned. In Groovy, it's like a collect operation. So basically, it's like a collect operation, only you put the function that you're calling in front of it.
In front of the for?
Yeah, in front of the for. So what we wind up with is this then returns and builds a list for each value returned, and then that list gets returned from the function because it's the last argument. So we can take that a little bit further, and we can do something more with it. So this time we've got a function where basically we want to take all those numbers and we just want to return a filtered list that shows us all the ones that are divisible by 3. So that's effectively all the thing that is before it is doing. Equals a function that takes an argument of the divisor. My maths is atrocious, so if it's the wrong terminology, get over it. I mean, sorry. So we want to return the number, yeah? So that's what I'll return. So for so that looks familiar, but obviously that's we still need to filter the value out.
That's
So
just return a list of the same numbers.
that will just return a list of the same numbers, which obviously is not what we want. So what we can do is we only return when the divisor mod when number mod the is equal to 0. Now, in JavaScript, I've already committed a bit of a crime. So in JavaScript, equals, that's not the same kind of equality. The way that you should be asserting things in JavaScript for equality is triple equals. There's a bunch of reasons for that. I read some of the examples. You can look it up, but it's a common gotcha. But because equals just isn't really useful, CoffeeScript turns equals into the triple equals, because that's what you do, isn't it? Because that's what he figured it should have been in the first place. But it also likes, so the guy that wrote it really likes interfaces, really likes languages that are very descriptive, that really, the language is to tell the reader of the code what the code is doing, every bit as much, or if not more, than telling the computer what's going on. So he would prefer us to use is. Okay? So that applies to a bunch of other operators. So there's is, there's isn't, there's instead of ampersand, which is the traditional JavaScript for saying and, it's just the word and. It's all there in order to make your code as legible as possible. So what we wind up with is we loop over each number, and it's only at the point where our condition here is met that we actually return the result. So the result of this so we can see now that we've got our if statement in there, and it only pushes the results into the list if it matches that criteria. So anytime that you're finding it difficult to follow, just fall back to the JavaScript output. So, right. Something that we really missed from our time in Groovy Land was multi-line strings and string interpolation. So, I mean, this looks fairly normal for building up a string that includes, there's some variables in there, so where we're dumping age in. It's a multi-line string, but really we just kind of want it assigned to one variable, so this really doesn't look so bad when it's on a full-size screen. But let's see what this would. So what we get in CoffeeScript is we actually get multi-line strings, and we get some string interpolation. So we can translate this into. So in order to identify it's a multi-line string. That look familiar to anyone? It should look familiar to a number of the Scala or the Groovy programmers. So, and then so this is the interesting part. where we actually then declare when I come across hash and braces, it's a substitution token effectively, so I can then embed my name in there just for completeness, what it would be if this would behave. So it starts to look a bit more readable, and we start to understand what it is that we were trying to get at in the code above. So that's a good idea. It doesn't care, but as long as you do, that's the important thing. So actually, let's try it and see what happens. No, let's not try that. Boom! It thinks I'm in HTML. No. So, CoffeeScript, where are you? So, looks about as garbled as the first example. Very familiar. But that improves the code clarity, the ease of programming. Right. The next example is effectively, JavaScript has a bit of an issue with the definition of the word this. So this doesn't necessarily mean what you think it means unless you're careful. And in this example, actually I haven't been careful, because this function here will get passed around, and it depends on the context in which it's run as to what this actually means in its context. So there's a bunch of tricks you can use to get around this, but effectively all I'm trying to define is I'm trying to define a class that's got some constructor parameters, binds a function. So to make it feel a little bit more familiar to the object-oriented people, we've got support of classes, which have constructors. Now, constructors can take arguments. Now, I'm going to put an @ sign in front of these. There's a reason for that. And that is because as soon as I stick the @ sign in front, it implicitly refers to this. It implicitly, effectively, means what I don't have to do now is declare this.name equals name, this.age equals age, etc. Because when I compile it, that's what it's going to put in for me. So it saves me a bit of trouble. But then when I declare where are you? Tell you what, I'm totally losing it. Event. Then it is so declared a class. It's got a constructor, takes the parameters, holds on to them, it binds a function. Now you notice that I didn't actually put any parentheses here. Parentheses are optional in CoffeeScript. I'm giving the example that it's optional because when you actually embed functions, it feels much more friendly to have the function on the end and not have to worry about a bunch of closing parentheses. But in the fact that they're optional, that means it has all the side effects of Scala. It's optional until it's not. And there are edge cases where that will catch you out. So I typically, if I'm not passing a function in, I'd put in parentheses anyway, but it's your call. It'll support it. Now, what I've also done is you'll note there's a small difference. This is what CoffeeScript defines as a fat arrow, as in it binds the context of this, whereas this doesn't bind the context of this. So if we ditch that, then we'll see that it's injected a little something for us. So CoffeeScript tries not to inject too much magic, but every now and again in order to support the stuff it's trying to do, it does inject the occasional extra function.
Does the amount of underscores before the variable denote how much magic it's injected?
I said he got some inspiration from Python. Underscores, they rule. So single underscore means it's private, double underscore, it's magic. So no different from the Python idiom in that regard. The other thing is, because it does a compile step to JavaScript, if there are any variable clashes, it'll work it out and it'll change it, stick a 1 on the end or a 2 on the end, whatever it needs to. So you don't need to be conscious of what it's going to produce if you don't want to. So
that's a weird way of getting this sorted out.
I like to look at this as, bytecode.
Yeah.
I don't read bytecode very much, but I do know enough JavaScript that it's useful. And the nice thing about it actually compiling to JavaScript is then you can use all the JavaScript libraries. You can use all the JavaScript libraries from CoffeeScript directly, and everything lines up nicely.
I think the scary thing in JavaScript is the convention is when you have a this within a this, they call it that. And so you actually make that equal this, pass that equal this.
You just rename it to t'other.
yes.
Right.
Yeah, and I've seen code where it goes this to that, and then there's another function where it has the other, and it just goes on and on and on. And you
It
get
gets
to the point
nuts.
where you think, what am I talking about? What's the right point?
Well, and this effectively takes away that problem by giving you a fat arrow. So fat arrow, probably no more meaningful than that, but all it means is any anonymous functions in there, run them in my scope, not whatever scope they turn up in. So effectively, that's just a very small taster of CoffeeScript. Dependent on whether or not everyone's in the mood, because we're using this in AFU, we've done this, it was important to us that we could run it as part of our build pipeline and that we could test drive it. So I've got a little...
Chris, I'll ask you a question. How have you bundled it in? Because you're running TextMate, that has not a plugin that
It's
compiles into...
It's just got a bundle. So behind it, in order for the bundle to run, you've got to have Node.js installed. And you've got to have the CoffeeScript Node package installed, and that'll give you that support. It is possible to actually run CoffeeScript directly in your browser, and that's a nice way to play with CoffeeScript. It's not the recommended go to production with it like this. The recommended is compile it to JavaScript, then minimize it, and have a nice day. So you do need a few extra tools to get that to work. Okay. So the last thing I wanted to show you was we actually have done all of our Java code, our CoffeeScript code, the same way as we did our Java code. We wanted it all test driven. So what I've done is I've just worked through the first few tasks of a bowling kata. So just the idea of how do I score bowling. So you can see that when I look through my tests, a bowling frame, it should start with a 0 score. Should not be complete when no balls have been bowled, etc. So we move through the steps iteratively. And this isn't really a story on how to do TDD so much as this stuff is TDDable. It works quite nicely for us. So as you can see, if I then run my tests run at the command line. They give me they give me the kind of JUnit style output, which is picked up fine by my build process. Now I've got all of my Jasmine tests, that was the test framework that I'm using there. Output, put into Jenkins, made part of the standard build process. So it's quite possible to write robust TDD, properly developed CoffeeScript. So I'd recommend that.
Describing it as Jasmine syntax.
So describe, effectively this is to follow the BDD approach really of just describing, providing a spec of what your app should do. So obviously I'm not going to go into too much detail because it's not really a Jasmine overview, and there's a lot of syntax which are part of the Jasmine DSL in here. It's quite rich, it gives you mocking support, you can spy on constructors, and it's all quite neat. But I would strongly recommend that if you wanted to start using CoffeeScript on a production app, that you look at Jasmine as a way of making sure that you can do all your good coding practices. Now, last, because I'm just going to stop at this, I think, is if I can find the right file to open. I was trying to get my son's been interested in programming for a long time, and has been asking if I can write a game with him. And I said, well, what would you like to write it? And he said, well, Python, you love Python. I said, well, where do you want to run it? I want it on the internet. Well, okay, we won't do it in Python then. So, so we had a little go at writing a game.
How old is he?
11. So, I don't know if anyone had a BBC or the Commodore 64 when they were growing up, but if you want to have a look at some CoffeeScript, it's all in GitHub. Anyone that's interested can email me or just have a look on my account, which is Tarttelin on GitHub.
Some
And
interesting
you'll find
graphics
it.
you've got.
It is, isn't it? Yeah. I didn't say either of us were any good at this, just that we worked on it together. It was fun. So yeah, it's nice for writing that sort of thing. It was good fun. Okay, that's it.